Good morning, everyone. We're going to go ahead and get started here in about a minute. We'll just let everyone else join. It looks like we got quite a few people here, so we'll get started here soon. Thanks. All right, we're going to go ahead and get started. Thanks again for joining today. This is our fourth or fifth webinar in the series so far. Today we're going to be talking about heat pumps. We have a great speaker with Terry Tarantine. And yeah, let's go ahead and get started. So as a reminder, all of our attendees are on mute. So if you do have any questions, there is a chat bar to the side that you can throw your questions in and we'll get to them at the end. And then a recording of this presentation will be available on the website after this presentation has concluded. If you do have any follow-up questions, be sure to send them in through either the chat function on the website or you can email us and we can get those questions to Terry and I'm sure he'd be happy to help you out. So real quick agenda. My name's, do my introduction real quick. My name's Fred Seiler. I'm here at Clear Result as the marketing account manager for a few of our clients and happy to have you all here today. We'll go through our sponsors, some additional educational opportunities. Then I'll hand it off to Terry and he'll do his presentation and we'll do a quick Q&A session to wrap it up. So again, a big thank you to all of our sponsors. We couldn't do this webinar series without them. Typically we do this in person, so they were all gracious enough to let us convert this to a webinar series, and we've seen some great successes with that in terms of the engagement that we've gotten after each session. So again, thank you to our sponsors, Consumers Energy, Semco's Energy Waste Reduction Program, Efficiency United, UPCO, and DTE. Again, as I've said in the past webinars, if you're not taking advantage of this additional education opportunity, please do. We have Mark Jewell, who's well known within the industry of energy savings and how to get there, doing a 6-part webinar series. It's Thursdays 1:30 to 3 p.m. Right now, actually, you can view the sessions online on demand and whenever you want to. So be sure to take advantage of that. If that time doesn't work for you, you can view them on demand. So this week's webinar is about optimizing sales management. That's going to be on the 5th, not the 3rd. So apologies for not updating this slide, but that will be on Thursday. But again, you can view that on demand. So it really should be available to you when you're ready for it. Again, it's a $588 value and it's no cost to registered trade allies with Semco's Energy Waste Reduction Program and or Efficiency United. If you're not a current trade ally with either of those programs, be sure to reach out and we'll get you set up. Register at sellingenergy.com/Michigan. Again, if you have any questions, there's always the chat bar at the conference website. And then our grill kits that we're going to be handing out at the end of this webinar series. So if you attend 2 or more webinars, we'll be sending you this in the mail. We'll be reaching out pretty soon here to get your mailing addresses and any information. So be sure to at least attend 2 of these seminars so that you can get that. And then without further ado, I'm going to hand it off to Terry. Terry is the Director of HVAC Sales over at Young Supply and Comfort Engineering Solutions. And he's also a proctor for Young Supply's EPA 608 certification and yoga pipe and RGF systems. So Terry, take it away.
All right, thank you. I'm going to talk about commercial heat pumps today. And as a like-for-like comparison as much as possible, I'm going to try to stay with the 10-ton systems. And we're going to use 70 degrees or as close as the data allows us to for an indoor temperature, and 5 degrees as an outdoor temperature. 5 degrees is typically around where most of our design temperatures are from, I would say, Saginaw on down. Although when we are designing systems, we'll typically, for heat pumps, use -10 as our design temperature. And we'll see that some differences when we get into those low temperatures and the different types of systems that are out there. One of the things that some of these systems allow us to do is size these systems incredibly carefully. I mean, incredibly accurately. We can get right down to the BTU. And when we get outside our normal temperature envelopes, this can cause us some issues. The other thing we found is that in the design phase, what we're designing to on a print and what gets built into the building and how it gets installed isn't always the same. So we like to have a little bit of capacity, extra capacity to cover those situations. So we're going to start out talking about the 3 main types of commercial heat pumps. There's a 4th one that we're going to get into towards the end. Unitary, this is what you're normally used to seeing. These are your rooftop units, your split systems units. We're seeing a trend now towards heat pumps with gas heat furnaces. This has become very popular on the grow room side of the business. We're seeing more heat pump applications going into the grow facilities in Michigan. When we talk about geo, water source and geo systems, this is where we're pulling or rejecting heat from the ground or a water body or a water loop system, which many of you have in larger buildings. And what we're doing there is we're taking, transferring heat amongst the building. We're using a chiller and a boiler, and we're starting to see some heat pump chillers come into the market as well to gain some efficiency. These are very good at heat transfer, and they lend themselves extremely well to heat recovery. And that's becoming the biggest focus of heat pumps these days, is we want to transfer heat amongst the building. We'll talk a lot more about that today. And then the newest entry into the system, which has been, well, it's not new anymore. It's been around in the US for about 20 years. And that's variable refrigerant flow, VRF. Many of you may have heard of this. Some of you are very familiar with it. But variable refrigerant flow systems are the fastest growing heat pump segment in the commercial market by far and away. And if we look at the chart below, we're talking about some COPs. COP is basically just coefficient of performance. I have a little explanation there, but I'll go over it. It's all kind of based on electric heat. Electric heat, for all practical purposes, is 100% efficient. Just costs a lot per BTU. So electric heat COP is 1. You put in $1 of cost, you get out $1 worth of heat. We're going to talk a lot about heat with heat pumps, more because we know we have enough cooling capacity. We're really designing towards heat. Talk a little bit more about that as well. So if you look at the top chart, just an air-cooled unitary heat pump, this could either be a split system or a rooftop unit, somewhere between 65,000 and 135,000. So again, we've got that 10-ton range that we're trying to compare to. They have a COP of 3.3. So if you're at 47 degrees, which is the rating for this, you put in $1 worth of energy, $1 worth of cost, you get $3.30 worth of heat back out of it. And as we look down, VRF heat pump at 47 degrees, also 3.3. In the bottom two, we're starting to get into the water systems. We have a VRF water system, which is a very, very efficient system. And then we have a water source heat pump. And as you see, the coefficients of performance are all pretty good, 3.3 through 3.7. But the water is based at 50-degree entering water, and the air is based at 47. So everything's reasonably equal at those efficiencies. However, when we start to get into some lower temperatures, we'll start to see where a couple of these systems really outshine the others. Go to the next page. 47, where did we get that from? The Department of Energy requires all heat pump manufacturers to rate their equipment at 47 and 17. So you'll always see those performance data out there. But typically when you're getting into the VRFs and the water source heat pumps, you'll find publications down. We typically 0, -13. Some of them have gone significantly lower. We'll see an example of that in a little bit. One advantage a water source heat pump has over the VRF systems is in the amount of refrigerant that's included. VRF systems, we're using refrigerant to transfer heat around the system. Water source heat pumps, of course, we're using water. So the more refrigerant you have, we start to run into some code issues, and that's ASHRAE 34 and 15, where we're talking about refrigerant concentration limits. For most applications, we're allowed 26 pounds of 410A, the primary refrigerant we're using today, per 1,000 cubic feet. And some institutional, like assisted living, memory care, different things like that, we cut that in half to 13. So it is something that we'll talk about a little bit more at the end, but we need to be aware of that in our design phase. And we just talked a little bit about the ASHRAE. Here's an option where we have water source heat pump, and this is also very similar to what you're going to see in VRF. This is the heat recovery mode. Here we're using a water loop system. You can see the chiller and boiler in the bottom left. And if you look at the various heat pumps inside, you'll notice that some of them are in heating, some of them are in cooling. At this point, what we're doing is taking typically internal spaces where we're needing air conditioning, and we're transferring that heat via the water, or in a VRF system it would be via the refrigerant, to the outer zones where we need heat. So now we're not buying energy, we're just transferring the energy around the existing building envelope. So this is where a lot of the system design is coming in. Let's say you have the south side of a building that gets heat, the sun in the morning, we need cooling. The north side of the building doesn't have the sun, so we need heating. We just transfer it from one side of the building to the other, or from one area of the building and typically internal to outer areas. And this is where the real energy savings with heat pumps come in. We're starting to see things like modulating compressors come in. This is where VRF has especially shined. Modern code requires everything be 2-stage above 5 tons. So we're going to see some different options on the comparisons between this efficiency and that efficiency based on the staging as well. So this is becoming a very popular design system where we're sharing the heat in and amongst the building's envelopes. And then we have an optimal system, which is a VRF with water source. Typically our COPs of 4.5 in any climate. It really doesn't matter what the outside temperature is, doesn't matter what's going on. When we have a water source VRF system, our COPs over 4.5, and I've seen as much as 5.2. So again, every dollar that goes in, you get $5 worth of heat out. We're starting to see some of the unitaries move up in their efficiencies and performances. We'll see an example in just a minute, but we're talking about your Trane, your Rheem, your Carriers, Lennoxes. They're starting to put modulating compressors into some of their systems. We're seeing this more on the residential side currently, but as we move through the years, we're starting to see this come into the commercial side. So we'll see more split systems and rooftop type units gain in efficiency and gain, more importantly, in capacity. If we can heat and cool the building, it doesn't matter what the efficiency is. And we're typically, again, sizing these on the heating requirements, because if it can heat the building, we know we have plenty of cooling. And that's where the modulating systems really come in shine, because we can modulate that system down, gain even higher efficiencies on the air conditioning side because we sized it for the heat. All right, a little bit of an eye chart here, but if you look, there we go, perfect. If we look at, this is a new 10-ton heat pump packaged unit, rooftops type system. And if you look along the top, you'll see 70 degrees. We'll take that middle point at 5, which is the second column down. So at 5 degrees with the 70-degree indoor air temp, we're getting about 50,000 BTUs out. Less than half the capacity of the cooling system. Again, this unit has meets all the new criteria. This unit does meet the new 2023 standards that are coming out. You're not aware, everything is changing come 2023 on the commercial side. New efficiencies will have to be met. New systems are being designed by all the manufacturers as we speak. And this particular manufacturer has come out with this unit that will meet the 2023 standards already. This unit was recently introduced, so this is relatively new information. And as you see, just under 51,000 BTUs at 5 degrees. Okay, here's the split system. We have the cooling data on top, and you can see the full cooling. If we scroll down just a little bit, you'll notice there isn't a lot of change when we go from a rooftop to a split system. This is an air handler and a outdoor condensing unit heat pump. Again, at 70 degrees and 5, we've gained a couple thousand BTUs. We're right around 52,000 BTUs of heat. Still not a lot, but better than we did on the package system. Water source heat pumps. This list shows 6 to 25 tons. I chose this particular sheet because we are trying to maintain that 10 ton, but just be aware that these systems do go down to fractional tonnage as well. And we often see this in water source heat pumps. We'll have a multitude of smaller systems in an office building doing zoned heating and cooling for different spaces. In this one, we look at both vertical and horizontal models. The vertical goes from 6 to 25 tons. The horizontal goes from 6 to 10 tons. If you look at the next page, we start to see some options here. If you're looking at the bottom part, right just above center, you'll see the HBH and HBV 120 full and part. That's the two-stage that we're talking about. And we have 3 different options here. We've got the water loop heat pump. This is our straight water source heat pump. We've got typically a heat pump chiller. We'll have a boiler in the system as well, a chiller in the system, and we're transferring the heat in and around the building using water source heat pumps. Then with that same system, we can apply that to a groundwater system. This is where we have typically a well, or maybe you have a body of water on premises, a big pond, something like that. And as you can see on the water loop pump side, we're getting significant capacity out of this. Whereas the 10-ton unitary system was around 52,000 BTUs. At full capacity, we're getting 160,000 BTUs out of the heating side of HBH 120. Even at partial load, first stage operation, we're at 78,500. And if you look just next to that column, you'll see the COPs are very impressive at 4.7 and 4.6. So you're getting almost over 4.5 times the heat out per dollar put in. It drops off just a little bit when we get to the groundwater system. We went from 160,000 output to 132.5, but we're still at a 4.0 COP. And then the part load, we're still staying at 4.0, and we're getting 64,500. And then to the right side of the column, this is a ground source. Basically, we've dug a trench, we've buried the tubing into the trench and put the dirt back over it below the frost line. But still, even though our COPs have dropped below 4, we still have over 3. We have 3.3 at full and 3.5 at partial. And again, you see the corresponding BTU outputs of 53,800 and 103,000. Still double what we were getting out of the unitary system. Okay, if we move to the next one. Here's the VRF. You'll see that the VRF has very similar outputs to the water source. In this particular slide, if you look at the very top, you'll notice that this manufacturer has listed their capacities all the way down to negative 21.6 degrees. And at that negative 21.6, it's still putting out almost 68,000 BTUs of heat, more heat than the unitary 10-ton did at 5 degrees. And if you look at the top of the shaded column, there you'll see the 5 degrees, and we carry that over to the 70 degrees. You'll see that we're getting over 130,000 BTUs of heat output from an air source heat pump at 5 degrees. We're accomplishing this through modulating compressors and a technology called flash injection. Basically, we're ramping the compressor up past 60 hertz, which normally drives a lot of heat into the compressor windings, and then we flash inject refrigerant. It absorbs the heat, and then we transfer that heat into the space and reject that heat into the space when we're in heating mode. An incredibly efficient way to do this, very efficient. We can run, again, there's no shut off on this. It's rated down to negative 21.6, but typically in our design phase, we're using the negative 12.6 or the negative 7 that you see on there for our design to make sure we have plenty of capacity. And because these are modulating systems, we're not quite as concerned with a mild oversizing because the system will modulate down to meet our loads. Next one, please. Here's a submittal. Another advantage you'll see for variable refrigerant flow, and if I seem to be biased towards this, we do distribute all the systems shown. This is something that we spearheaded and we've had incredible success with. You notice that there's a very small footprint. These are modular systems, typically sized to go into an elevator. We'll just couple modules together to get the capacities we needed. A couple things I do want to point out here. This is a 10-ton system. If you look in the electrical box to the left, you see that the maximum current protection, maximum overcurrent protection is only 40 amps. This is less than a typical residential 5-ton standard efficiency system. Very, very, very low energy usage for a 10-ton system. Going down into the piping, you notice that the pipes that come in and go for this, the refrigerant pipes, 1/2 inch and 1.125" copper connections. Very, very small piping compared to the capacities. If you look to the right, you'll notice under the unit data, the fourth section down is sound pressure, the decibels. It's only 59 dBA. 59 dBA, to put that into perspective, is about the same as a 2-ton residential system. And may I say, a very quiet 2-ton residential system. So again, these units are incredibly quiet. Typically, we'll see these, we'll put these in old mechanical rooms where maybe there was an air handler and a boiler before, but very often we'll just put them right up on the roofs. And concerns about sound levels for other occupants, next neighboring buildings, maybe they want to put a patio on the roof. With these sound levels, we've done this successfully without any problems. We go to the bottom of the page where there's some accessories. A couple of things I do want to point out. You'll notice on the left, optional accessories, there is a low ambient baffle kit available. We can run these in critical cooling applications where we'll get full cooling capacity down to 0 degrees. And then we also have a base pan heater. The base pan heater is very important in that we are running heat pumps below 0 degrees outside. So they will frost up, and we run defrost cycles. The base pan heater is there to make sure that we don't freeze the condensate water in the base pan. We want to make sure that that water drains out completely. And even though we can run these down into 0 degrees for cooling, we typically put the critical cooling applications on their own system and don't make that part of the overall system, just because we want that to be its own thing for critical cooling. This would be your IT rooms and such. Okay. And here you can see an extremely small footprint. Again, fits right into an elevator. And here we just give some performance data. Our efficiencies, 12.5 EER and 13, depending on whether we're using ducted or non-ducted systems, and we'll show some different options there. And again, you'll see the 47 and 17 that DOE makes them put out. Again, very impressive, over 3.5 for the 47 and still over 2.5 on the 17. Okay. I grabbed this application because it's something that we're seeing a lot of in our market, and that is the hospitality side. And this goes not just for hotels, but we're also seeing this in office buildings, where one of the advantages VRF has over all the others has been on the noise side, the sound level. When rooftops start up, when water source heat pumps start up, and especially PTAC units in hotels start up, they're very noisy, or they can be very noisy. Water source heat pumps are typically near the space, and that's the compressor is mounted inside that particular unit. So you have multiple compressors throughout the building, and they can lead to some noise issues, whereas VRF is incredibly quiet. Very often the occupants don't even know the system is running, it's that quiet. So that is an issue for a lot of hotels. And then efficiency. Between water source heat pump and VRF, it's a direct net savings to go to that higher efficiency system. And here's a chart kind of showing the decibel levels. We said that that 10-ton unit was 59 dBA. So if you look towards the middle there, that's about normal conversation level. And again, that's a 10-ton outdoor unit running locked in at 60 hertz. So typically they're running less than 60 hertz. They're even quieter than that. And they show some different options there. VRF system, it's a single refrigerant circuit that we can connect multiple units to. And this goes as well for water source heat pumps. A lot of them share some similar characteristics. We get zoning. Both systems lend themselves to zoning extremely well. One advantage VRF has is we have a number of options on what we put inside the room. We see some ducted options. This particular manufacturer has an art-cool unit in 9,000 and 12,000 BTUs. They can put family pictures in there. A lot of hotels really like this type of a unit. It's quiet, it's unobtrusive, and it's decorative. And then we do have a multitude of different control options, and they're very, very energy efficient. Little comparison here. PTAC units, there's nothing simpler than a PTAC unit. They're simple, they're inexpensive. They are expensive to run though. In the typical area, you get what you pay for, and you're looking at energy for a commercial building. Energy is a direct net cost. So you have to make an awful lot of money to recover for the net. They're typically not particularly quiet. In fact, they can be considered noisy. Aesthetics, we've got the wall penetrations going through the building, so there is a sacrifice to the aesthetics of the building, and they are inefficient. Rooftop units, simple, relatively inexpensive. What we lose out on the rooftop units on heat pumps is in the colder temperatures, we don't produce enough heat to heat the space. So then we're falling back on electric backup heaters, and then we have a significant loss of energy there. 2 and 4 pipe fan coil units, very expensive to run. We do have a lot of maintenance cost on these with the water systems. Then water source heat pumps, very efficient, certainly less expensive to install than a 2 or 4 pipe fan coil, but they are still maintenance heavy, maintenance intense with the water systems. You could have boilers, you could have chillers, there's pumps involved. And typically when water source heat pumps publish their efficiency data, they don't always include the pump data in there. But again, very efficient system, but we do have to compensate for the space there. Those units go into the spaces and we have to put them somewhere. Typically they're mounted in ceilings. VRF, again, small footprint, typically up on roofs. We can run extremely long line set lengths. And we show here that even the water source side of it, very compact little units, and they are modular. We just couple them together to get the efficiencies we're looking for. They're also available in single phase, and we're seeing single phase smaller units becoming much more popular. We've got some operations going down in Florida right now, large towers, hundreds of tons per tower, and they're all individual single phase heat pumps. So again, it's becoming a much more popular side. Here they're just talking about footprint and weight. When you're putting these up on roofs of buildings, especially when we're doing a retrofit job, maybe the building's been abandoned for a long time. I think the David Whitney building in Detroit was a good example. It was abandoned for 20 years. Roof had not been maintained. So weight was an issue on what we put there, and we were able to spread the weight out with the VRF system and managed to heat and cool that building completely using nothing but heat pumps. We can run a long way as well, and this also applies to water source heat pumps. Water is easy to pump, refrigerant's even easier to move around the system. Here in this manufacturer showing that we can go 738 feet on a run, and with a total equivalent piping length of 3,280 feet. So we can cover an awful lot of distance off of one small unit. Again, they're showing different options for the indoor units. They do notice, Fred, go back. You notice that they do have some ducted options here. The ducted options go all the way up through 8 tons. So we can cover some big spaces with ducted units. And a lot of times where we're using ducted units in these heat pump applications is where we've got a lot of little rooms. Remember we talked about the refrigerant concentration limit? If we have a lot of rooms to cover, rather than going to multiple outdoor units to cut down on our refrigerant loads, we'll use one ducted unit and cover a larger space. All right, thank you. And again, simultaneous heating and cooling. Water source and VRF do a great job of pulling heat from one space and transferring it to another. So again, this is that scenario we talked about where one side of the building may be in sunlight and needs heating. Another spot is not in the sunlight and needs heating, or needs cooling and needs heating. We can just transfer those BTUs around from one spot to spot. And space. We talked about how small the piping was. For instance, a duct opening, again, using our 10-ton example, you can see 20 by 39 versus 2-inch for water pipe and less than 1 inch for a refrigerant pipe. So again, when we're designing our building spaces, and space is money, we do have some significant advantages with water and refrigerant versus air. And this was eQuest is a energy program, and we looked at, we're taking Chicago, Illinois as our source here for our market. And here, just a comparison of water source heat pump, fan coil units, and PTAC heat pumps. And you can see easily PTAC heat pumps are the least efficient system out there. Again, while they're the least expensive to put in up front, they're the most expensive to run. And our goal is to use less energy. The world is changing. We need to put less CO2 into the system, and a VRF puts in the least amount of CO2, followed by the water source heat pumps. PTACs put out the most. And cost. Well, the equipment side of VRF is a lot more expensive, very comparable, let's say, to a water source. The overall installed cost is typically less than a 4-pipe fan coil, very similar to water source, a little bit more than you would have with the VAV system. VAVs are kind of an older technology, very inefficient. And then again, we have our packaged rooftops and split systems. For our market, those really don't come into heat pump applications very well, just because we don't get the heat output for them. We're seeing these in grow rooms where they work pretty well for the grow, where we don't need as much heat. But for our most applications, we're not using heat pump split systems and package units. And the other advantage VRF has, it's got a built-in building management system. It's a DDC system right out of the box. If you have an existing BMS, it's easily integratable. We can tie it into your front end, lawn, back net, whatever you have. VRF systems will integrate in rather easily. Another option we've got on the VRF side for heat pumps is we can take an existing older air handler and we can convert it to VRF. We've proposed this on a number of churches where they wanted to add air conditioning. And by adding coils to their air handler, putting a variable frequency drive on their motor, we're able to give them an incredibly efficient system for both the heating and the cooling side. And what we found in many of these is the energy savings on the heating side has offset the cost of adding the air conditioning. So even though they've added air conditioning, their overall annual budget for energy doesn't change much. And that's been a tremendous advantage for a lot of churches and schools in particular with these big old air handlers. And here they're just talking about some other options we have. We don't have to heat air. We can also use rejected heat to heat water. Here they're showing pools, kitchens, bathrooms will preheat water, take some of the load off of what we have for heating the water system, saving on gas or electricity. We've even seen some systems where we've done in-floor heat. Although that's a little bit more complicated design, that is becoming more popular as we go through. Dedicated outside air systems, one thing that we do need to do with all these systems is to add fresh air, becoming a more and more important part in the COVID era. So I just want to point out that we do have to address the fresh air separately from the system. Again, it will tie in from a control standpoint, but we need to address fresh air. It's one advantage rooftops have is they have auto economizers that automatically bring in fresh air for us. And if you're going for lead, VRF is probably of all the systems, along with water source heat pumps, easiest way to get your lead points. Here you can see that there's points for VRF, there's points for filtration, points for DOAS outdoor air units. If you monitor CO2, there's points for that. And as Fred was saying, all of your local utilities are looking to become more efficient on the commercial side. So check and see if there's some offers for you, some rebates and different things that perhaps you want to go for to help offset the cost of your installation or your conversion. And here they're just talking about some different efficiencies. Maintenance, let's talk quickly about maintenance. One of the big advantage VRF has is it's almost, I'm not going to say maintenance free, but it's basically just clean the coils and clean the filters. And that's pretty much the maintenance schedule for a VRF. There's no water that has to be, or chemicals that need to be done. So that is one really big advantage that that has. All right, PTAX. This is literally hot off the press. This was sent to me yesterday. We are seeing two manufacturers. This one shows LG, Friedrich is the other one, where they are coming out with inverter-driven PTAC units. Inverters are modulating compressors, so they're trying to integrate some VRF technology into some lower efficiency typical systems. And what they've done here is if you look at the unit data to the right, you'll see that the EER is 10.5. This is significant gain in energy efficiency, but they were able to maintain that 42 by 16 footprint. So we could retrofit existing systems to these higher efficiency and more importantly, much, much quieter hotel units. So this is something that we're going to see a trend towards. And if you notice also that they have a manual intake air damper. So now we can also lower our efficiency, lower our cost of running, lower our sound levels, and introduce the fresh air that more codes are requiring. So this new unit is very exciting for us. It's something that we'll be working with the utility companies to incentivize changeover, because this is one area we can gain significant energy advantages. And here we're talking about some ASHRAE standards, again, on the refrigerant concentration. If you are looking at a VRF system, please make sure that your designers are designing correctly for the refrigerant concentration limits. Very often as we're bidding on prints, they'll come through and we'll see that no attention's been paid to that. Where we'll have to take maybe a 40-ton unit, break it into 220s or 410s, depending on how they've got it set out. So if you're looking at VRF, make sure that your designers are up to date on their ASHRAE standards. Just a little bit more about the different concentrations in refrigerants. And that concludes. Any questions?
Great, thanks, Terry. Looks like we don't have any questions in at this time, but if you do have any questions, we're gonna open it up right now. So be sure to put your questions in there. We'll leave it open for just a minute. Terry, did you have any parting thoughts on heat pumps and the efficiencies people can gain from them?
Absolutely. Again, when you look at energy savings, it's a direct net cost savings. So when we're looking at heat pumps, and more we're designing 2 heat pumps. Even on the unitary side, one area that we're really pushing heat pumps is on the grow room or the hydroponic side, where we need significant cooling. So it's that 10 tons of cooling that only put out 50,000 BTUs of heat at 5 degrees. When in a grow room application, that's plenty of heat. So now we can have the advantage of a lower cost rooftop, save on, make it a heat pump and save the energy there, and still provide enough heat. Or maybe that 50,000 is enough heat in an office building, it's plenty for a grow room. So again, the energy savings that we're getting from this, and we're starting to do more heat recovery where we're pulling heat from the plant areas and we're transferring it to the office areas. Again, so it's now instead of buying energy, we're just paying to transfer that existing energy around the space. Significant savings on energy.
Great, thank you. It looks like we don't have any questions. I'll just add that, of course, make sure to partner with your utility. Most utilities are looking for ways to, reduce their energy load. So if you are looking into this or any kind of efficiency upgrade, be sure to check in with the utility. There's usually some good incentives or rebates to kind of help cost share that upgrade to your building. So always be sure to include them. So again, thank you, Terry. Really appreciate you helping us out today. And for those that are still here, we have another presentation next week on the 10th. It'll be at 10 a.m. It's with Sherry Holman. She's the executive director at U.S. Green Building Council of West Michigan. So again, November 10th, it's on Tuesday. And we'll be here. So be sure to register at mienergyconference.com. And if you have any questions or want any of the presentation that Terry gave today, be sure to reach out on our chat feature at the website. Thanks again and have a good rest of your day.
Thank you, everybody.